Okay. Does it work? Yeah. So good morning. Thanks for joining my talk. So I have the pleasure of starting with the first talk during this conference. My name is Reyk Floeter, or try to transcribe it in katakana and Japanese, so maybe it helps you. I'm from Germany and member of the OpenBSD project. And so today I want to talk about OpenIKED, which is actually quite interesting because OpenIKED is my first daemon, my first software that I wrote in OpenBSD that is portable and also running on other systems, including free NetBSD and even Linux. But I will talk about this later. I implemented several other tools on OpenBSD, but normally it's only for OpenBSD. Well, except the stuff that got ported. So if you're a FreeBSD user, you probably know the wonderful network driver LAGG, which is called trunk in OpenBSD. And so somebody ported it and renamed it. But this is something I wrote for OpenBSD as well. So now I want to talk about OpenIKED. My agenda for this talk: little history, why did I start this implementation, the background, then the design of it, and in the very end I will talk about the portable part, the specific things there. Or in the GUI, well, you will see later what it means. it's not the most important part, but it matters in some way. So, here's a good question. OpenIKED is a new implementation of an IPsec VPN. And the question is, why do we need another VPN protocol? We have already so many VPN protocols. In the default OpenBSD installation, we already have IPsec with ISAC-KMPD, we have NPPPD, which was contributed by IIJ, so we can do all these protocols, L2TP, PPTP, IPsec. Does NPPPD support any other VPN protocols? That's all. So okay. So at least we have them. We have OpenSSH, of course. Some years ago, I implemented a little hack so that you can use OpenSSH to do layer 2 or layer 3 VPNs using the TUN interface. But the neat thing is that it still works and it runs on Mac OS, on Linux. On Mac you can even use the default OpenSSH version that is installed and do VPN with this SSH version. So, but this is not very well known and it has some problems. It is a very specific tool. And yeah, there's OpenVPN. In OpenBSD it's part of the ports or packages. Yeah, whenever somebody asks about VPN on the OpenBSD mailing list, you can wait a little bit and somebody will reply, well, you can use OpenVPN. So this seems to be like a standard answer. Actually, I don't really like OpenVPN, but it seems to be a really common solution. Yeah, on the other side, there are SSL VPNs. So the good question is, what is an SSL VPN? There's no standard defining an SSL VPN. Okay, you have SSL TLS, a protocol, and you can tunnel stuff over it. And some vendors have their own SSL VPN implementations. Actually, Actually, Microsoft's SSTP is kind of documented, so it's not totally closed. They're doing PPP over HTTPS, and so it's layering, and they call it SSL VPN. So this is something that is available. I think every Windows supports it. And then the other vendors, they all have their different versions of VPN. So that's not standardized or interoperable at all. So, yeah, SSL VPN, as I said, you have all this layering, the overhead, and it's really only for specific use cases, for like road warriors who want to check emails, people with laptops, mobile users maybe, but it's not an ideal solution. IPsec is well, the strongest VPN, but it is known to be very complex and hard to configure, and it is based on RFCs, on standards. It's supposed to be interoperable, but all the vendors have their extensions, and then there are some problems, and even if they follow the same standards, there are problems with timers and so on. Well, OpenBSD does a really good job in working with many other vendors, but so the classic IPsec of IKE version 1 or ISA-KMP is not so easy to use. For this reason, many people started to use OpenVPN, but now, these days, OpenVPN, I would say it's for religious people, in a sense that people just say, you use OpenVPN, and they're not open to look at anything else. It's just like this one solution. Technically, OpenVPN is not the best solution anymore. Absolutely not. BGP MPLS VPN, I added it. I like the name, that's the official name. But that's something crazy, and it gives you virtual networks, but it's not really adding privacy here. So, yeah. If you want to know more about BGP MPLS VPN, you can probably ask Kenny more about it. So,
if you buy me beer, I might answer.
Okay, so later. Yeah, so the problem is there's lots of choice and different implementations, but we do need a VPN as a general purpose, as a strong VPN. We need something that is open, standardized, that is widely adopted. So it doesn't help you if it only works on a specific operating system. For VPN, I also need to care about Windows clients. I do need to care about Apple clients, even if I run all my personal stuff on open source. So this is obviously not open source, I'm sorry, but it's well, for me in the past when I was using only OpenBSD, it was quite special to see, well, I install a VPN gateway, so I have to care about the Windows users connecting to it. So we need a protocol that works
What's the other way around? You have to care about Windows users not connecting to it.
Well, doesn't really help you in the business and day-to-day operations. Widely adopted is also an interesting point. OpenVPN is a single implementation, so it's just one thing. There are not many different implementations. So with having multiple implementations, you have interoperability problems, but also it helps to improve the protocol by finding different problems, seeing it from a different perspective, and IPsec is far better in this regard. So I call it IKE version 1, but it's just IKE, the old protocol, and ISA-KMP Oakley. All these names describe the same protocol. It's the traditional IPsec keying protocol. It was a bit complicated because these days, if you use IPsec with IKE, you just use one thing, but the protocol is designed to be like a multi-layered thing. So you have the ISAC-KMP protocol running on top of a domain of interpretation, and on top of that you have the internet key exchange. But in the real world, this one combination of IKE and ISAC-KMP is really the only thing that is using the internet domain of interpretation. So this combination is designed to allow different protocols on top of ISAC-KMP. So the idea was they make like a framework kind of key exchange protocol, and then they can use different key exchange versions on the top or on the other side of the DOI. This is basically internet DOI is IP, but the idea was you can also use like raw Ethernet.
ISO.
What?
Net ISO.
Net ISO, for example. But it never really happened. Actually, I don't know, I think 10 years or 12 years ago, like some time ago, I implemented layer 2 based well, a patch for ISAC-KMPD that was using the IKE protocol to make a key exchange for layer 2, for MAC addresses and everything. Well, for that I had to implement my own DOI and all this. But this was crazy stuff, and I never pushed it any further. So it was before WPA came up, and so then I skipped it. So the good thing about IPsec or IKE version 1 is that it's everywhere, it's widely adopted. But on the other hand, it's also causing like network admins, firewall admins, people who need to configure gateway-to-gateway configurations and multi-vendor environments. It's causing headaches, right? So have you ever had to connect your BSD gateway to like a checkpoint or to a Cisco? It works normally, but there are all kinds of problems that can show up. But as I said, OpenBSD is fairly good these days in adjusting to the third-party gateways on the other side, by using the right timers and all this in a flexible window. Yeah, and a good thing is ISAC-KMPD and this protocol was implemented in OpenBSD in 1998, so it's ages, it's a long time. Like Niklas and Niels, they implemented it for Ericsson. I think Niels is like some leading security guy at Google now, but at this point they made ISAC-KMPD.
Niklas makes beer.
Niklas makes beer in Sweden, yeah.
So
this, the initial implementation of ISAC-KMPD was quite strange. The configuration used and style, well, I call it .ini style. You remember this old school, old style of configuration that you had on Windows 3.1, like this ini sections, and ISAC-KMPD was following this style of configuration, and actually it was hard to configure it correctly because you had to write everything into the file, and if you missed like a specific section, crypto definition, and so on, then it didn't work. So it didn't have any default configuration. You had to put everything in your configuration file. So there were lots of how-tos and tutorials on the net how to configure ISAC-KMPD. So the configuration was really difficult. On the other hand, OpenBSD was the first operating system that shipped with IPsec by default, enabled. I was really surprised that, like in the other BSDs, IPsec is still not enabled by default in the kernel. Yeah, the generic kernel of freenet BSD and Dragonfly BSD and whatever else exists and is not derived from OpenBSD. All of them have IPsec not enabled in the generic kernel. You need to recompile. OpenBSD has IPsec enabled since 1998, or a bit later, but for a long time now. So, to fix the situation with ICTL, something else showed up many years later. I think it was around 2005 or 6, around that. Hans-Jörg Höxter, a Bavarian OpenBSD developer, or no, he was from Franken, that's a different part of Germany.
Austria.
No way.
So, too many Germans in this room. Okay. So, to make it easier to configure ICTL, he implemented a tool that allowed to configure a really human-readable and nice configuration, and this tool translated it to the ICTL, the .ini style of configuration. So it was more or less like a compiler, I don't know, yeah? It was translating this one language to another language. So to simplify it a bit, it was able to feed, well, it still exists, it is able to feed the generated configuration directly into the running ICTL daemon. So you can start ICTL without any configuration, with this policy engine that was a different experiment in ICTL turned off. So you could start it, and then afterwards, in the second step, you can load the configuration from these new style of configuration, the new grammar, into ICTL. So this is the current situation if you want to use ICTL and OpenBSD and IKE version 1, the old protocol. So the problem is you always first have to start a daemon and then load the configuration. Well, you can do it in the init scripts, of course, but it has some problems. So like proper reloads of the configuration don't work. So you cannot.
So sorry, please use the microphone.
Does not work?
More volume, please.
Ah, okay. Yeah, so I don't have a clip to fix the microphone here. Hello?
Yeah.
Okay. No, that looks stupid. I'm sorry. Yeah, so I just try to be a little louder. So this double solution is a little bit complicated. ICTL still supports the old .ini style configuration, so you can do both. For some configuration options, you have to use the old configuration file and then load the new one. So it is nice. I think still it's the easiest solution to configure IPsec. It's much easier to compare to Raccoon, but because you can use a single line to set up like a fully authenticated IKE connections with certificates and everything. You use a single line of configuration. I don't have an example here, but I will show an example about IKE later. So it is good, but not the best. So then later a new protocol showed up, Internet Key Exchange version 2. And the good thing about this protocol is something happened that is really rare. They managed to improve the protocol. That's amazing, isn't it? They have a new version of their protocol and it became better. They made it smaller. They removed features. So they removed this ISAC, KMP and DOI layers. That doesn't exist anymore. You just have the IKE version 2 protocol now. there's no need to care about net ISO anymore.
That's right.
So, and they changed the IKE version 2 payload, so of the authentication packets, the way the encryption and the authentication is part of the packet, to look more like the ESP, which is like the data encryption part of IPsec. So the control channel part of messaging is using a format that is more like the data channel messaging. Before it was totally different. If you ever used IPsec, you probably also heard about aggressive mode and main mode. So you had two different modes to authenticate it. And actually, aggressive mode has security problems, but with main mode you cannot connect in some scenarios like mobile users. So some vendors kept on using aggressive mode, like Cisco, with some extensions, and while others use main mode. So in IKE version 2, there's one new authentication mode, so you don't have to care anymore if it's like aggressive or main. And cookies is a way to protect it against like denial of service attack. They're actually optional, but the implementation can decide when it enables cookies or not. But we don't fully support cookies yet at the moment, so. But it's okay. You don't have to change anything in the configuration. It will happen like in the background. It's not part of the configuration. One thing has been improved, like as I said, pre-shared keys with main mode and mobile users, so people who have like a connection and like a dynamic IP address, so you don't know from what IP address is this user coming. I'm not talking about roaming where the IP address changes, just about the fact that your user's connecting from unknown IP addresses, from a hotel or a wireless hotspot. So, and this didn't work with pre-shared keys in the past, because you had to use the IP address as the authentication ID, basically. And now you can use pre-shared keys. So the standard is quite interesting about this, because they say, well, you should not use pre-shared keys, of course. You should use certificates and a stronger authentication. But they fixed it. So I think it's good for quick testing and some setups like internal networking, maybe, I don't know. But it's really mostly for testing. And for me, for the implementation of IKE, I was happy that I got pre-shared key working before I got the certificate authentication working. And one last interesting fact about IKE version 2, it's covered by a single RFC. Of course there are extensions and proposals and some vendors adding their whatever dreams, but the basic IKE version 1, where was it? Oh, well. You see, just to do the basic implementation, you had to implement 3 different RFCs with all these revisions. And IKE version 2 is just a single one. The new one just replaced the old number, but there are only minor changes actually, improvements again. Okay. Just a summary for people who used IPsec in the past. They changed a few names, so there's some terminology. You probably now, in the OpenBSD world, we call it flows. In other IPsec implementations, it was called like security associations. One security association could include multiple security policies. A policy is what we call a flow in OpenBSD. In IKE version 2, this is the closest match to policies are traffic selectors. So this is basically a range which tells you what area will be protected from IP address to IP address and port to port. The interesting thing here, and this is something we do not support in our implementation, is that IKE version 2 doesn't use like net masks for their traffic selectors, they use IP ranges. So, just don't have it here. For example, a traffic selector can be to so I'm really sure that this does not match like a normal net mask, right? So I'm not talking about the source and destination address here in this case. So probably from to is the wrong terminology. This is more like this. Yeah?
Completely different now.
Yeah. Well, from a grammar point of view. So this is the from range. This is the range you want to protect. It's a range of IP addresses. We do not support this in OpenIKED. The reason is, what we can do is, like, I don't know, what is this? Maybe. We can do net masks. Our kernel, and I think the traditional Karma implementation in the other BSDs is similar, is using the routing subsystem to look up the flow.
Not really, it just looks like it.
But it depends on the semantics of the routing. So to implement ranges, you cannot use this radix tree anymore. You need a completely different matching.
Sounds like a good thing.
Ranges?
No, having to use something different than radix trees. It's a good thing.
Okay. Well, you can implement it that we can do ranges. Well, so what we do at the moment, we actually convert our net masks that you configure to ranges and advertise it to like the Windows host, to the other host, and it's just a limitation. But you cannot do like this single IP address ranges. So traffic selectors. IKE SA was called the phase 1, phase 2 is called child SA. There's also phase 1 had two names in IKE version 1. It was phase 1 in quick mode, and phase 2 was also called main mode. So now it's IKE SA and child SA. Yeah, initiator responder is the same. Okay. So let's go to IKED. The picture shows like the green grass here because it's like a new implementation from scratch. We were looking at IKE version 2 for some time, and some people we were thinking if we should implement IKE version 2 in our existing IPsec daemon in ICTL. There was even like an initial diff to support this, but we skipped this idea because adding like a new functionality to ICTL is really like putting a brand new engine in a really old car. Yeah, it doesn't make sense. You have these really scary implementation with a configuration style that nobody liked, and internally the way ICTL was implemented in '98 was totally different to the way we do networking daemons in OpenBSD now. Yeah, so IKED is a complete new implementation, but internally, technically, IKED looks at way more than the other networking daemons in OpenBSD. Like BGPD was one of the first daemons that defined the style that we have in OpenBSD.
It was the one defining the style, basically.
Yeah, well, I say one of the first because OSPF it was using libevent, and BGPD is not, right?
No, I wrote BGPD without, because for BGP there was no point.
Yeah.
For OSPF we changed the framework to just use libevent underneath. Yeah. But that's not a big change, really.
So, and then there is some, I wouldn't say evolution, because BGP is not worse or something, but there are some changes. So now we have a number of daemons that are following a specific style of like configuration grammar, how the implementation is done. They all have privilege separation. That's absolutely important. I will show how it works in a moment. Any networking daemon that we do, well, anything that runs with some privileges uses the privilege separation model. We have
some simple stuff just drops pros.
Okay, yeah, simple stuff like ping, for example. Yeah, but that's not a daemon.
No.
Sorry. This configuration style is different. Looks a bit more like, we'll say, like PF, but only a bit. But it's a grammar that is human readable. You can do stateful config reload. So the good thing is you change the configuration, you reload it, and by default the running sessions will continue to run. Yeah, it's a behavior that we know from PF. If you have established states, a configuration reload will not flush the states. It's very convenient. There are firewall implementations that disrupt all running states when you change the configuration. I've seen sysadmins who were firewall admins who were really scared about changing anything in the configuration because their product before disrupted everything on configuration changes. So in PF it's natural that it doesn't do that, it just keeps on running. In ICTL it was not. Like changing the configuration normally required to kill the daemon, start it again and reload the configuration. And then wait until the tunnels are up again. So with IKED you can statefully reload, established sessions will just continue to run. Well, we also try to improve the usability of certificates, handling them if you use X509CA. I will show this in a moment. And well, I choose to use OpenSSL for everything SSL and crypto related. I know others are moving away from OpenSSL, but it's much easier. ICTL actually had some custom cryptos like Diffie-Hellman, for example, implemented. Later I took the code that I wrote for IKED, the Diffie-Hellman, that is using OpenSSL instead of the custom crypto, and also merged it into ICTL. I'm actually sometimes touching ICTL, but I really don't want to. Is it still okay? So, no, wait, this one. So IKED is the daemon that's running, and ICTL is the control tool. That's the same style we have also like BGPD and BGP-CTL. Oh, I still have time, I think. I started later. So I can talk longer. So see, ICTL, you can control, reload, and monitor IKED, and it includes a tool, we call it ICTL-CA, which allows to make a really simple certificate authority. So everything you need to create a CA that can create certificates and keys, so it combines the key and certificate step, so you have all the trust basically. So you can create them and it will sign them and install. So just these 6 steps are enough to create a CA with 2 hosts and 2 certificates. That's all. It's all well documented in the manual page. So of course you can use a full-featured CA and use this standard certificate, but in most cases, when you administer small networks and everything, this is very useful. You can also revoke certificates, generate a CRL, of course. So we try to make it as simple as possible. It's not designed to be a replacement for web servers. It's just for IKED. Okay, I hurry up, but I don't have 100 slides.
I don't know how much you have left. Just a reminder.
Design and implementation. Well, this model here is an illustration of privilege separation. It looks very wild. The idea is, there's a pointer here. So this part basically, well, this is IKED running as a daemon. So IKED, when you run it, you will see it will run 3 processes. One process, the parent process, they are all part of IKED, but normally in PS you see the different process names. You will see a process that's called CA. The CA process is something that's like it's change routing to the etc IKED directory where all the keys and certificates and all that is installed. So we have a separated process that is in charge of all the confidential information basically, and it's for certificate looks up, for signing packets and so on. So that's like the CA process. And the IKE version 2 process, in this case, is responsible of handling like the network connections. So it's listening to these UDP ports 500 and 4500. It's parsing the messages, the sessions, and so on. But whenever it sends like an authenticated packet out to the peer, then it sends these parts that needs to be assigned to CA. The CA does the stuff and sends it back. So IKE version 2 process will never see the private keys. So the idea is when somebody manages to crash IKE version 2, maybe even exploit it, then they still don't automatically have access to the private keys. This is quite a unique design, I think. Actually, the CA process, this concept got later, the guys who are working on OpenSMTPD. There's a talk tomorrow, I think, from Eric about Open. They adapted the CA process from IKED. So IKE version 2 is handling all the protocol implementation. You see here is like a wide IKE version 1 process. It actually runs, but it's empty. It's doing nothing. When it receives a message, it sends it to the IKE version 2 process. But at the moment, it's basically disabled. So the idea was, well, maybe we could implement IKE version 1 someday, but it's really more about making IKE version 1, if you really need it, talk to IPsec KMPD to use like an internal socket or some internal communication to pass IKE version 1 to IPsec KMPD. Because at the moment you cannot run both versions at the same time. So I don't really want to care about IKE version 1 anymore, but a simple solution could be to use the IKE version 1 process and let it talk to IPsec KMPD and patch IPsec KMPD a little bit. Instead of listening to an outbound network socket, you use some special kind of internal. That was easy. But maybe we just implement it at some point. Yeah, in the kernel. ICTL is talking to the parent, and the parent is just responsible of like reloading and sending the new configuration to our process. Actually, when I looked at this picture, it was parent, CA, IKE version 2, and I did some sightseeing in Tokyo. I was really reminded about IKED here. You can see Uh, I cannot really pronounce it. How's this intersection called again?
Shibuya.
It's
Yeah,
well
Shibuya,
known.
right?
Yeah, Shibuya is it.
Yes, Shibuya. Yeah, Shibuya.
Okay, so this is a place where you can sit in the Starbucks like I did here and visit the people wandering. I'm a tourist, sorry. So here you have the parent. The parent actually is feeding the processes with new configuration items, right? And the CTL is more like the train station part of it. It's getting requests of new configuration. The kernel actually is here. Why? Because IKE version 2 is directly talking to the kernel that's via PFP version 2 at the moment. And the kernel and the parent are not directly connected in this case. So this PFP version 2 is the interface that the IKE process talks to the kernel to install the flows and policies. Okay, and there's some network stream coming here. Okay, IKED, I hurry up. It implements strong crypto. So SHA-2 at the moment, but also like AES modes, modern AES modes. AES-GCN is a really interesting thing. It's a mode that combines encryption and authentication, so you don't need an HMAC anymore. It's AES only. It's supposed to be secure. I'm not a crypto researcher, but it's AES 256, and in these there were several iterations of counter modes, and AES-GCM, the Galar counter mode, that's combining these both steps, is a strong security, is also what is used by several governments, and you can offload AES-GCM to the hardware. Well, it's not really offloading, it's directly using the Intel CPU instructions of AES-NI. So when you run IKED with AES-GCM, in OpenBSD we fully support these CPU instructions on modern Intel CPUs. So all the encryption and authentication is fully done in the CPU and in hardware, and that's 100 times faster like this. So it's a huge difference. And we do elliptic curve cryptography and all this modern fancy crypto. Yeah, IKED is interoperable. Windows 7 shipped with IKE version 2 support by default. And it's really easy to set up, really. It used to be hard on Windows to set up IPsec, but IKE version 2 is just basically entering the gateway address. And then you have also installed the certificates or buy an official certificate. Linux StrongSwan, there is a version of StrongSwan that does IKE version 2. And some network vendors, Cisco, Solaris, and actually very interesting BlackBerry 10, they support IKE version 2 in their smartphones. And they use it for roaming. There's an extension, Mobile IKE, and so you can use your BlackBerry, make voice calls or data calls, and you roam from wireless to 3G, LTE, whatever else, and it's using the IKE, the VPN connection to BlackBerry or to your company to keep the session running. So you have this layer, and Mobile IKE allows to do roaming. So really, I need a BlackBerry to test this feature, but just the new ones. Mobile IKE is what I said, is something I want to implement. It's not supported yet. It's supported by Windows and BlackBerry and some other. Basically, it allows when your IP address changes because you move to a different network to restart the existing IKE sessions. So it will just a simple authentication, say, okay, my IP address changed, and then your tunnel keeps on running. You don't need to re-authenticate it from scratch again. Okay, some other things I want to implement. Radio support is really missing at the moment. Yeah, I really need to look in MPPPD, and MPPPD does some radio. At the moment you have to configure all the users in the local config file. That's not nice, I know, but we want to replace it. So how does the configuration look like? This is a simple configuration that you could use between OpenBSD and OpenBSD, or IT and IT. Just a single line, and everything else is based on defaults. You can add more options to change the default encryption and so on, but one line would be enough. The second example is something you would use for a Windows mobile client. So Windows is using MS-CHUB v2 for user authentication in addition to certificates, and then you could assign an IP address to the client and so on. Something that I also want to implement is to use like pools to dynamically assign IP address, a bit like DHCP. The tag option is something specific to OpenBSD that's not portable to other systems. It tags the packets, and you can use PF to filter every packet that's related to this IPv2 connection. Okay, last but not least, the portable OpenIKED project. So I had IKED implemented, and now I wanted to connect from a Mac to an OpenBSD gateway with IKED. And Apple does not support IKED version 2, so I ported IKED to OS X. And I didn't want to use strong swarm because it's huge and complex and I don't want. So I ported it to OS X. So my first port was really to Mac OS. And yeah, this is how the idea started to make a portable project. And until this point it was just called IKED, and then it became OpenIKED, and I got an artwork with the tin can phones and Puffy or mascot, and started this page OpenIKED.org. But really, in OpenBSD we just call it IKED. Link here, secure, so we have to configure goals, so you can read them on the web page. Portability is so how is it done, the implementation? The core development still happens in OpenBSD. So the code that you can find in OpenBSD's source tree does not include any compatibility glue. So no if-def netBSD, sorry guys, no configure scripts, it's just like a code that was written for OpenBSD with a classic BSD makefile, and it just runs. This is how we do portable code in OpenBSD, also for like NTPD and all the OpenSSH, the others. And then there's an outside portable version, which is basically adding the configure script, the if-defs, like well, you cannot see this here, the compatibility library for OpenBSD specific functions. So you can compare these two source repositories, but it will always be separated. So the core team, the core development happens in OpenBSD, and then the portables part, there we try to make it portable. And if a feature like the tag is not supported somewhere else, then it would just be an empty stub. That's the situation at the moment. Well, I did the most of the work of implementing and porting it at the moment. If you want to port it to any other system, I don't know, most of the interesting ones work already. If you need something BSD-like, you need strong crypto, it doesn't make sense if you just have DES support. Or OpenSSL version 1, that's important because in some systems, like on the Mac, there's only OpenSSL 0.9, and you have to install OpenSSL 1 extra. With event version 1, it probably works with version 2. I've never tested it because in OpenBSD and base we have version 1 still. And you need a kernel with IPv6 support. There's no on-off for IPv6. And a Camel compatible stack that supports the PFT version 2 protocol. There are two variants of PFT version 2, the OpenBSD style has historical reasons, and the everything else style. Okay, almost done. Supported operating systems at the moment, of course, OpenBSD, but here you shouldn't use the portable version, it's from the OpenBSD tree. Apple, Linux, then Linux, say PFP version 2 is deprecated since many years because they have their own superior API, but it still works without problems. So I hope they don't remove it. The only problem is with PFP version 2, SHA2 256 doesn't work because they implemented it incorrectly, but they don't fix it because they say, well, it works with a new API, so why should we fix it? NetBSD and FreeBSD, these are just the version numbers I used during the porting. And Dragonfly BSD, I installed it and then it was asking me hammer questions and then I gave up. So, but any Dragonfly BSD person here or developer or porter, I could need help here if you want to port it. Last thing, the graphical user interface, that's a screenshot from a Mac. So the goal is to have like a little GUI that's as easy as you configure it as a Windows IKE version 2 client. So you basically put in your gateway address, optional description, and you can add some details, but you don't have to. And then you push connect, and it works. That's something I want to give like roaming users, and then that's fine. This is not released yet, but it will be open source, blah, 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 blah. You will find it on the OpenIKED page soon. I'm not really a GUI developer, but something as simple as that is possible. Okay, conclusion, VPN is still important, even in an age when everything is about HTTPS. We need to build connections to private networks, even in the cloud, if you have network as a service and all this, VPN is still important. IPsec is not that, but IKE version 2 is going to disappear. All the important vendors, the vendors are adding IKE version 2 support now.
IKE version 1.
Sorry, IKE version 1 is disappearing and IKE version 2 is taking over. You get what I mean. Mobility is a main selling point of IKE version 2. Maybe Apple will support it one day, I don't know. They could just use an existing BSD licensed version, but we see. I hope not. And yeah, OpenIKED is still a fairly new implementation compared to IPsec KMPD, so it's not perfect yet, but we can already use it. Danke, we say for arigato. So, well, I had 53 minutes, I'm not sure because we started later. But if you have urgent questions now, otherwise you can ask now, otherwise you can ask me all the day.
All the beer.
All the beer. So are there any questions now? No? Yes?
Will you try to test iPhone iOS?
You want IKE version 2 from iOS?
iOS VPN.
So connecting from an iOS device using its VPN software to your daemon.
Is there a solution to run IKE version 2 on iOS? I don't know. I don't think that I could run my custom VPN on iOS because Apple does not allow me access to PFP to the kernel API from the sandbox. So it could work with Android actually. I was thinking about adding support for Android, but I don't have an Android device. That's always the case with so yeah, it would be nice to have it on iOS as well. I will have a look at this at some point if there's any way to do it, but with Android I know it works. You have access to the relevant APIs. Yeah, any other questions? question? Okay, so we are late a little bit, so thank you again, and we can talk later.